So today we're going to still continue with review for, oh, you guys don't have this up here, sorry. Probably want to see the notes. What happened? Okay. That was weird. Alrighty. Okay, so as mentioned, we'll go through these lecture 6, exam 1 examples. So again, review as far as next Wednesday will be the exam. This Tuesday, you'll have your group work or individual work due. So again, if you're individual, you need to do 2 of the problems. If you're a group, you need to do at least 3 problems amongst your group. You want to create your own problem of either RC, RL, or RLC problem, and then solve it, and then give it to your group teammates or post it to get some feedback if it looks correct or not. So the goal of that is to help you to prepare for this next exam. So I would pick a problem that you need more work on to be able to do that. You can do something as simple as use the same problem, but just change it slightly, add in a different resistor somewhere, or just change the values, whichever one, or totally create a new one, whichever way you would like. The exam will be in the Engman lab, so it will be during the same time period, and you'll have 50 minutes to complete it, and so you want to just be right ready at 10:45. I'll open it up like at 10:40, so if you can't even start earlier, you're welcome to. And then you'll have a full hour from 10:40 to 11:40, but I know some of you have class before and after, so it will be designed to be done in 50 minutes. So RC, RL, RLC questions, there'll be some understanding questions, and open notes, open books, no open neighbor. You can use MATLAB, you can use Wolfram Alpha, any online simulators, Python, Java, whatever programming you would like. The only thing you cannot use is the simulators, so just not a circuit simulator to solve the problems. So everything else is fair game, but a circuit simulator. If you want to pre-write scripts, you're welcome to, and then you just make sure you're taking screenshots of your script in case you have an error in there, and you'll get partial credit. So just make sure you are taking snapshots of all the work as you are doing it in case your answer is not at the end correct. All right, questions? All right, again, for those that are online, if you're going to be taking it and plan to do it remotely, make sure you do reach out to me, and I will send you an individual link for your proctoring so that it can be recorded. Oh, one other thing. So on your screen, I'm going to want you to have all of your windows open and then tiled next to each other. So I don't want to see like a browser with lots of tabs on them. Just each browser have a tab, and then you're going to rearrange on your screen so that I can see everything that you have open, if that makes sense. And so online also will be the same. Huh? So yeah, you're gonna be on the computers, yeah, for everybody, because for those that are gonna be here, you'll be upstairs and I'll walk by, and so that will make it easy for me to see. If you like to have extra monitors, you can bring your laptop and then a connector and actually have another window there. Some of the students use that way, or you log into the computer there and you have your laptop and use both windows, and just again tile them so that it's easy to see what you have on your screen. Does that make sense? Okay. All right, any other questions about the exam? Okay, so there were some requests to do some problems that were multi-sources, but before that, there seemed to be some questions, and I think it actually boils down to understanding what a circuit can be solved with. So is the circuit RLC if it's parallel or series, or you cannot actually solve it with the techniques we have up to this point? So that's what I wanted to first address. So in these, I wanted to first look at these as far as identifying, is the series parallel or neither, where you can't actually use the techniques that we've done so far, okay? So I think this may answer your question, Carly, that you had when you were saying, like, how do you have it when you have another resistor in between there? Because you actually can't. And so I think that that might have been the reason why you were struggling with maybe a problem. So first one, let's look at this one. Oh, that's very large. So series, parallel, or neither? Okay, so to determine that, you are going to look at the switch at the end spot. So that would be open here. And then you can hopefully see that these would then be in series. So correct, this would be series. Okay. Anybody have questions about that being in series? You can see it. Okay, let's do this one. So look at the end position, and in the end position, it's going to be closed, which will look like this. What do you think? So somebody said parallel.
Part of me wants to say parallel, but I feel like that short in the middle of that just doesn't make it work that way.
So with that short there, this becomes its own circuit, right? And this becomes its own circuit. So it is neither. So this would be that you would have to use an RL for the left side and solve it using RL techniques, and on the right you would use RC techniques. And you would solve them separately. Does that make sense? Okay, so neither, yes, Hiram.
Would you expect to see something like that on the test where it's neither?
Possibly, like I could ask you some questions about the circuit, and you would have to identify that this is RL or RC, and I could ask you, like, what is the initial value of VC? Or the end value of VC? Or the beginning, initial value for IL and end out value for IL? Or the equation. I guess I could ask you to solve either one. So you do want to be able to identify them. All right, this one. Oh, yes, Marley.
Wouldn't, like, at the final, why would we need to solve for the RC side? Because there's no, like, sources over there.
So for the final one, VC would be 0. But initially, you're going to have a voltage across it of 12 volts.
Oh, okay.
So it would still have, you would do your final plus initial minus final, e to the minus t over tau. And then tau would be 4 times C value.
The capacitor still discharges, and we might build off that circuit in such a way we need to know how it does.
Yeah. So it's going to start off at 12 because of the initial value will be open in that switch. And so with the capacitor open, those will all be floating, and so there'll be no current initially. And so the voltage will just be the 12 volts. So it will go from 12 volts to 0 in an exponential curve. And then you can find the tau for it. Does that make sense? Okay. And then on that left side, the inductor will start out at 0, and then in the end, it will be 12 over 3 will be the end value for IL. And so it will go up to a value and be exponentially go up to it. So it will start at 0 and then exponentially curve up to it. Okay. Kyle, did you have a question?
No, that is.
Okay. All right, any other questions about this one? Okay, so you gotta be like, look at the end circuit and be like, what is going on here? Okay. 3, what do you guys think? Where's the switch gonna be?
It's neither.
Okay, so it's gonna be in the middle. And so you have VL here and C over here, and you can see that the nodes on the top and the bottom of those are not the same. And so that will be neither. And we will get into next section how to solve those circuits. Okay? Any questions about that not being either of those? What if, oops, that was not there. Wrong one. What if this was a wire instead? Does that make any difference?
There's still resistor and source in
Correct. So because of that resistor and 6, the L and the C are not in parallel to each other. The C will be in parallel to that 3, but then it's in parallel to the whole branch of L, R, and the voltage source. So again, it's still neither. Okay? All right. All right, this one, number 4. What about this one? So the switch opens at the time, end time, so I'll have this.
It's also neither.
It's what?
It's also neither.
So neither. What do others think?
I feel like it's also
Neither because of the 5 ohm resistor.
I would make that into both source.
So where's the current flowing here? Goes to, oh.
They're in series.
So it goes here. If this becomes a wire, all the current goes here, and then it goes the same current through there, right?
It would still be series at the end.
This would be series.
So if a resistor is in parallel with the capacitor, then it's neither, but if it's in parallel with the inductor, then it's in series.
So if I had this is what you're saying, this would be neither. But if it, in this configuration, because the current is all the same, it will be in series. So maybe also, so you can look at them like, where's the current going? If it's the same current kind of flowing in one branch, and thinking about the inductor as a wire, in this case, you kind of have to know what's going on with the 5.
We could solve like one part of that as series, but then there's gonna be the other current through that resistor that we have to solve for as well, but we could use superposition to handle that.
I think the 5 ohm resistor, it's at the end, and the current going through there is 0,
So
so.
in both cases,
Go around it on the wire.
it will become a wire. It's only at the initial stage will the voltage across it be different. Because initially it will have no current, and then, I'm not going to confuse you more though. Let me
At
just
that
stop there.
initial stage, like, we would do it at like time 0 minus first.
Yeah.
And then at 0 plus, we put in a current source for the inductor.
Mm-hmm.
And so in our like 0 plus, still technically, like the way we're looking at it, there would still be 0 current going over the 5 ohm resistor, correct?
At 0 plus, you're going to have a source here. Think about this. Oh. And this will be open. And this will be a voltage source.
There could be current going through that.
Yeah, you'd have to analyze the full circuit to kind of, you'd have to find the voltage.
It would, the.
Drop across
inductor
it.
current is not gonna change though.
The inductor current won't change, correct? Yes. Okay, so hopefully you can see that this one will be series. And I know this is a little confusing with that. So then you kind of have to think about, well, where is the current going at the final time? So with that, that would be a wire here, and then all that current is going to flow through there. So final, it makes that a series. Okay. This one. 5. Okay, so final time here, you're gonna have it closed. So what do you think?
The left-hand side would be a series RLC, and the right-hand side would be an LR circuit, pardon.
Correct. So you would solve them kind of separately. All right, questions on that one? Or is that one easier to see? We're at 6. Okay, this one. Closes at time equals 0. So we're gonna have this circuit.
All right.
Kyle, did you have a question?
No.
Oh, you're stretching. Okay. All right. Parallel. If you don't quite see that, you can color the nodes. And you can see that the coloring across each one is going to be the same. That puts it in parallel. You have Didn't see it? Yes, see it? Okay. All right. Any questions on that one? You guys good? Yes, Kyle.
So, in the initial stage, with that switch open, and with the, looks like the voltage shooting current into the negative terminal of the capacitor, are we assuming that it's non-polar? And then we can just have a negative voltage on the capacitor?
Yeah, so you would end up with a negative voltage, most likely. So when you drew it, you could either swap the polarity and make it positive, or leave the polarity plus minus and put minus whatever value. Oh, sorry, I missed a chat. Yes, you can use your own laptop with MATLAB if you want. Okay, we're at 7. Okay, this one opens at time equals 0. And you are right there in series. Okay, is this helpful?
Yeah.
Okay, so you got to kind of identify what is this circuit. And I think the one on the homework was more like this one, and it actually might have been in series with that resistor in between them. So I don't remember. Nobody sent me a screenshot. I think Jagan was going to, but he didn't. All right, any other questions on this? Okay, so we're going to look at this problem. It has a couple sources in there, and we're going to try and find the right expression. I've already marked which one it should be so that I make sure I do the problem solution right too. Go ahead and work on this. Make sure you can see the value for C. C is 1 over 360. And then that switch opens at time t equals 0. Do you find these easier to do when they're multiple choice?
I feel like most things are easier when they're multiple choice.
You said what, Marley?
I said you still have to do all the math.
You do.
It really changed.
Yeah. Okay. I think with multiple choice, it's easy. Like you can see like, oh, the last one's not going to be it once you find alpha. Like that makes it easy to rule out some. I just am wondering time-wise if it might be easier to put a few of these that have the actual equation. anyway, I haven't figured out what I'm gonna do on the exam, so. by a raise of hands who's gotten an answer. Okay. Just a couple people. Okay, I'll give a few more minutes. Okay. Jacob, was the problem that you were asking about, was it also the same situation where it was actually a series and had the resistor in between the two elements? Do you remember? All right, so hopefully by now you found that it is in series. Anyone have any questions about it being in series? Hopefully everyone saw that. If not, practice some more to find out if they're in series or parallel, or why they're in series or parallel. Alpha for series is going to be RTH over 2L, and so that will be 60 nepers per second. Omega naught will be square root of 1 over LC, and that ends up being 60 radians per second. So they're equal, and so we're what? Critically damped. So with critically damped, go ahead and work on those if you haven't done that one yet. Got it?
Okay, so now, do you see that negative physics or? Okay.
All right, so solving at t equals 0 minus will be this circuit, and then I did known voltage. I noticed that there's no current flow here, is 0. So VC minus 36 over 6 plus VC minus 24 over 6 equals 0. And then I used Wolfram alpha. You can see my little snippet there, and it solved it for x equals 30. So VC is 30, and then IL is going to be 30 minus 24 over 6 to give me 1 amp. And then moving to t equals 0 plus, I see I have to label the current in the same polarity as was labeled originally. So that was labeled plus to minus. So IC I know is going to be going in this direction. With IC going in that direction, it's going to be a minus 1 amp as my current for my initial value. And so final, I have it open, and then IL will be 0, and VC will be, there'll be no current in these resistors, so it's going to just be the voltage 24 volts. And then B1 ends up being 30 minus 24 for 6, and then B2 ends up being a minus 360 and a plus 360 for 0. And so VC of t will be 6 plus 0, e to the minus 60t plus 24. So 24 plus 6e to the minus 60t. All right, questions about getting that? Any questions along the way? Okay. Vladislav, there's probably going to be 4 types of questions. So an RC question, RL question, RLC, and understanding question. So most likely 4 questions. All right. No questions about this problem? Everybody get it? Seeing yes and no. Okay. If not, go practice some more. Okay, so this one is the problem that I showed above. I thought it might be interesting to solve it. So it will give us practice doing both RLC and RL. So go ahead and find it for VC of t and for the IL going through the 2 millihenry. And then there's no current labeled for 1 millihenry, so you get to pick a direction for that current. That's weird. that wire at the top and the bottom. Could physically redraw them if it's fully, so when you have a common wire like that, you could actually draw them as separate circuits. So in the beginning, they do because you have, like when it's open, so before the switch, they do because you have current that just flowing all through the 2 milliliter, 1 milliliter, and faster. So that becomes a whole branch. But then once it's switched and that wire is there, remember wire can be drawn like, so I would put ground, and then once like you put ground, I think it's easier to see like, oh yeah, the air is really separated, and then I have that circuit to ground, that circuit I can even draw as separate ground there too. Yeah, so you would add both those currents coming into that one wire. Hopefully that helps visually see it different. So Marley, I don't know if this helps to see it kind of this way. Like they can be fully separated. And then like you were saying, like if I wanted to know the current actually flowing like together through that branch, you know, I could actually redraw this as like, oh, well, let me have both of them come in and kind of go to ground. And then I could find the current summation of both those together.
Okay.
And then that's going to ground. Hopefully that, I don't know if that helps or not, but. All right, so hopefully you found series on the left side, RL to be on the right side. And then RTHs. So RTH for the final circuit here is going to be 12. And RTH here will be 5. And so for series RLC, I have alpha RTH over 2L, and that was 12 over, and L in this case is 1 milli. So that's 6 times 10 to the 3 Nepers per second. And omega naught, square root of 1 over LC. And this is 6 micro. 1 milli. And this ends up being 12, 9, 10 radians per second. And so you have alpha is less than omega naught, and so underdamped. So series underdamped. Sorry, series underdamped. And then we also need omega D, which is the square root of omega naught squared minus alpha squared. So I'll just start with that one since I'm here. So this is 12, 9, 10 squared minus 6 times 10 to the 3 squared. And that gives 11,431 radians per second. And t equals 0 minus. This switch is open. This is an inductor. And then the capacitor is open. And then there's another wire here. And the current going through this, I would select the same polarity direction as that capacitor. So I would put it going from the left to the right. And so this will be IL, I'll call it just IL2. So IL will equal IL2, which equals 0, because it's just a floating wire. And then VC is going to be, there's 0 current here, is going to be the voltage on this side, which is 4 volts. And what's the voltage on this side? Not 0.
Why is it 0?
It's what?
Is it 6? Or 10, yeah.
Okay, so if there's no current going through these, then it's going to be the voltage here, which we can do just a Vx over 5 minus 2 equals 0, and Vx will equal 10. Did you see that, Brian? Okay. So Vc then is 4 minus 10 for minus 6 volts. Okay. So then at t equals 0 plus, which is where your initial value is going to be, this will be plus or minus 4 volts. The current source is 0. And this current source is going 0. And so IC, IC of 0 will be 0. VC of 0 will be the 4 volts, and IL of 0 will be 0. And then the final, sorry, I have no idea where I got 4 volts. Okay, so just kidding. It is minus 6 volts.
Yeah,
Okay, minus 6 volts. That's a weird one. Don't know where I got -4. Minus 6 volts. There another question? Okay, so minus 6 volts, and then in final position, the switch is still closed. Now this becomes an open and another wire, and then this is a wire. So what's IL here?
On the right side or the left side?
Yep, so it's 2 volts, or 2 amps.
On the right side?
Uh-huh,
Yeah,
right here, yeah. So going through that wire will be 0, or I mean, 2 amps because this has 0 current flowing through it. And then the voltage across here will be what? I heard somebody say it, 4 volts, correct. That one will be 4 volts. Okay, so VC0 was -6, -4 for -10. And D2 will be, what was C? Was 6 micro, but that's 0. IC0 is 0, so that goes to 0. So then we just have alpha, which was 6 times 10 to the third. VC0 again was -6, and then -4 over 11,431 to give a D2 of minus 5.25 volts. And then plugging that in gives a VC of T of e to the minus alpha, so 6 times 10 to the 3t, D1, which is -10 cosine 11,431 t. Note that that's multiplied. So 11,431, if I was to ask you a time, you would have to multiply that 0.5 micro by the 11,431 and then take the cosine of it. And then D2 is a minus 5.25 volts, sine 11,431 t, and then a plus 4. And then this can be, you can say for t greater than or equal to 0 or u of t. And then on the other side, we have IL of t, so it's going to be the final value, which is 2, plus the initial value, which was 0 minus the final, e to the minus t over tau, and tau will be RTH, which was 5, or wait, sorry, this is L. So L over R. And R was 5, and L is 2 milli. So this gives a tau of 4 times 10 to the minus 4 seconds. So IL of t will equal 2 minus 2e. And if I flip that 4 times 10 to the minus 4, that becomes 2,500 t. And again, you can do u of t or for t greater than or equal to 0. All right, questions? That makes sense. How to do these? Okay, requests for Monday. Any type of problems you want me to review more of? Which one?
The NIDER one.
Night.
We're looking into that, where it's like, not series or parallel, but.
Okay.
pretty
Okay.
sure.
All right, any requests online? Okay, so for here, the 0 in IL of the first part, okay. So up here, there's this is a floating branch. All this is a floating, sorry, not there. Get a different color. So all of this is a floating wire. And remember, in a floating wire, you have no current flow. So that's going to be 0 for that IL of 0. And then IL of 2 and IL will both be 0. So these are going to both be 0. And then when I draw them down here, because of this current source is driving that current to be 0 in that branch, IC has to be 0 because of that. So that's where you get IC of 0 in that one. Does that make sense, Dana? Okay, great. All right, any other questions online, or do you guys have any questions? All right, see you guys on Monday. Have a good weekend.
That's a lot of sticky notes.
Oh, I know. I've got a lot of, got to get through them.